Hi, my name is Avani,
And my name is Aaishi.
and we're both 5th graders.
And this is their science fair project. It's called Will the Marble Roll?
The purpose that we did this project for is that we wanted to find out, what was the minimum height to make the marble roll down the loop.
We were interested in physics, and so we specifically went into kinetic and potential energy and wanted to do a project that related to that. So we chose this project. In this project, we find out how, if the marble will loop the loop and if it will have enough kinetic energy to go through.
Our hypothesis was that the higher that the stand is raised, the more the marble will roll, but the lower it is, the more it will just stop and go back.
So these were the constants in our experiment were the length of the track, the weight of the marbles, the diameter of the loop, the length from the base of the stand to start of the track,
And then from the half point, this tape to this, and the distance, we are keeping the tape on the back of the insulator from the half point.
So our first step was to gather all the materials, which were the utility knife, the marbles, the duct tape, measuring tape, and the cardboard pipes. So step 2 is cut the pipe insulation into half vertically, so it forms like this. That way we could see the marble roll.
Step 3 was take the cardboard pipes and cut them into specific lengths. One that's 21 inches long, one that's 24 inches long, and one that's 30 inches long.
Step 4 is tape the pipe insulation to the cardboard pipe. Make sure the slope goes all the way down to the ground.
Step 5, make the loop, build the loop so that it's exactly 9.5 inches long, the diameter.
And make sure that the two sides of the loop are side by side. Step 6, you repeat steps 4 and 5 while using the different lengths of the cardboard pipes as the stands.
Write down what you observed and graph.
And these were results. For the 21-inch pipe, the marble stopped halfway and didn't go all the way to the loop. For the 24-inch pipe, the marble went all the way through the loop. But for the 30-inch pipe, there's too much kinetic energy, so the marble flew off the track.
And the abstract of our project is, this is what we're doing right now, is a basic example of what roller coaster engineers have to think to make roller coasters. So if the roller coaster goes off the track, it'll be too dangerous, but if it stops in the middle and go back, that will also be too dangerous.
So before we started this experiment, we did research about kinetic and potential energy in physics. Kinetic energy is energy in motion, and potential energy is energy at rest. These topics interested us, so we decided to do an experiment on it, and we chose this marble rolling experiment.
The variables that we found out in our experiment is that the independent variable was the height of the stand, and the dependent variable was the chance of the marble rolling down the slope.
And we measured the things in the experiment with inches and the weight in grams.
Our conclusion was that we found that our roller coaster track that we made that was 24 inches worked the best because it had the equal amount of potential energy and kinetic energy.
And we found out that it's pretty hard to be a roller coaster engineer because you have to find out the right amount, what to do with the track to make sure that the roller coaster doesn't fly off or stop midway.
You have to be a Goldilocks to decide which roller coaster is the best for safety.
And these were tracks. This was the 21-inch And
This was the 30-inch.
And this was a 24-inch, the one that worked.
We're going to roll the marbles down. First, we built the 30-inch one, so we're going to do this one first. It flew off the track.
And then we decided to lower it, so we did the 30-inch, the 21-inch.
It rolled back.
And I didn't have enough command points. And this was our final one, the 24-inch one.
It rolls perfectly.
Thank you.
For watching our presentation.